Welcome to Study Guide Forum. Today we'll be looking at some of the questions, some of the calculations that we saw in the Neco 2024 chemistry exam. In the theory, you notice that we have calculations like this, and many more of them we're going to be looking at in today's class. We want to revise them so that we'll be able to get the idea of how to really solve them in case if you're able to see them anywhere in time to come. And then before we continue, if you are joining us for the first time, we want to encourage you to subscribe and then share, like, and if you have any comment you can, or any question, you can leave it as a comment in the comment section there. And then all this question that you have here, I'm going to be leaving it there in the description of this very video so that you'll be able to read through and then get it. Perhaps if you're not seeing it very clearly here, you'll be able to see it clearly in the comment section and follow and then grab it very well. So now while we go ahead, now let's look at the number one question. That's the first calculation that appeared in that exam. Say that the chloride of an element X has the formula X chloride, that is X chloride. The formula is this: to have a X chloride sulfate 4 and a vapor density of 77. So calculate the relative atomic mass of X. We are asked now to calculate the relative atomic mass of X. This X here, what is the relative atomic mass? And we are given the vapor density. And now looking at this very well, you find out that vapor density is always two times relative molecular mass is always 2 times vapor density. That is to say, what we had here multiplied by 2 will give us the what? Relative molecular mass of this compound. That is, will be equal to whatever the mass of this will be. The relative molecular mass of this chloride will be. That is what it means. That is to say, since the relative molecular mass is equal to 2 times vapor density, which means what we have here is the relative molecular mass of this compound will there be 2 times 77. That will give us, let's go through it. 77 times 2, we have, what we have is 154. So if it's like that, and we know that from the formula, everything that we have in the formula, when we sum all the relative atomic mass of all these compounds, joining together is equal to what? Relative atomic mass. So that is what we are going to do now. What it means is that we know that X chloride 4 will give us the same. That is what it means. So in that case, we don't know X. That means X plus chloride. We know that chloride there is 4 times 3, 5.5. So when we do this, is equal to 154. 154. So 4 times 3.55 will give us X plus 142 equal to 154. So to get the value of this, which is what they ask us, the relative atomic mass of X will then be equal to 154 minus 142. That will give us, I think it should be 12. That will give us 12. That is what we have here for this first question there. So let's quickly go down to the second one. The second one that says calculate the mass of sodium carbonate in 250 cm³ of 0.1 mole per dm³ of solution. Now we are given the molar mass of sodium carbonate to be what? 106 gram per mole. So what are we going to do in this case? So what we are doing here now is that we have 250. We want to know the mass of sodium tricarbonate that will be here. And then we know that this is 0.1 mole per dm cube. Now there's something I want you to pick out from this place. We have this. This means that in 1 dm cube, the molar concentration of the concentration in mole of this sodium triisocarbonate is what? 0.1 mole. That is 1 dm cube. It contains 0.1 mole. Now there are two methods I can use to solve this problem, which I will want to go through fastly, immediately, so that we'll be able to apply the one that is best for us. So now to get this thing done, we know from this, it means that 1 dm cube is the same thing as 1000 cm cube, or also the same thing as what? 1 liter. So now, since we have 1000 cm cube to be equal to 1 dm cube or 1 liter of water contains what? 0.1 mole of what? Sodium triisocarbonate. So 250, now what? 250 cm cube of water will be equal to 0.1 over 1000 times 250 over 1. So when we do the calculation, what we have here, let me see what we have there. Let's do it with that. Let's just do the calculation so that it will be very, very clear. Times divide by. So what we have, the number of mole that we have there is 0.025 mole. That is what we have in what? 250 cm cube. Then if it's so, what the next thing we're going to do now is to find, because we're looking for the mass. We're looking for the mass. So we know that 1 dm cube, 1 mole of this, 1 mole of sodium triisocarbonate equal to what? 106 gram per mole. That is what we have from what we are given. This is the molar mass of sodium triisocarbonate. So that means 0.025 mole of sodium triisocarbonate will then be 0.05 times, that will give us times, we have, it will give us 2.65 grams. That is what we have. Now we're going to be using another method in solving this problem. The other method we're going to use here is to first divide it, find out the mass contained in this one 0.1 mole of the solution of sodium triisocarbonate. That is the first thing we're going to do. What we're going to do here is, when we find this mass, remember what we have. I think our final answer is this 2.65 grams. So now let's see what we are going to get if we use the same method. So that we'll be able to know the best way of solving some of these problems. You don't have to maintain yourself to stereotype yourself in one method. Sometimes one of them might be the simplest and the one that you can remember easily. So now the first thing we do, find out the mass of this in this. Since we know that 1 mole of sodium triisocarbonate is equal to what? 106 grams. Now 0.1 mole of sodium triisocarbonate will be equal to, that will give us something like 10.6 grams. 10.6 grams. That is what we have, just to be very sure. Yes, 10.6 grams. So now we have what is required in the mass contained in this dm cube. So what next are we going to do? So it means that in 1000 cm cube of water, it contains 10.6 grams of sodium triazocarbonate. So that means 250 cm cube of water will contain 10.6 over 1000 times 250 over 1. So when we do the same thing, times 250 divided by 1000. So you can see that we have again what we have is 2.65 grams. This is exactly the same thing. So that is one of the some of the ways of solving it, so that it makes it easier. If you know the one that is better for you, you just go ahead. That's just all about it. Depends on the question what you are asked to find, because in this case we are asked to find the mass. So let's just go to the next one we have there. The next question we have there is our next question there is that say that 0.75 mole per dmq of magnesium tetraoxosulfate 6 X hydrate, whose concentration is in gram per dm cube is 184.5. Calculate the volume of X, the value of X, in the magnesium tetraoxosulfate 6 S hydrated. So now we're going to find out, we're asked to find the value of X. And now we know that what it means that it has water of crystallization. S stands for the number of moles of water of crystallization. So what are we going to do here? We know that mole, to find mole, we know that mole is equal to what? Mass, or reacting mass. Reacting mass over what? We can say relative molecular mass or molar mass. Molar mass. So now, the molar mass of this, we are going to find out these things. We need to get this information. We have this, we have that, but also we have the, but even though it's not complete, we have it there. So we have the reacting mass, the reacting mass is equal to 184.5 grams. The mole, number of mole, or the amount of concentration in mole is equal to what? 0.75 mole per dm cube. This was a gram per dm cube. And then what again do we have? Molar mass. Molar mass will then be, so molar mass we have, in the molar mass we have magnesium is 24 plus sulfur, which is 32, plus what again? X plus what? When you add up everything about water here, we have 18. Oh, we missed something there. That of oxygen. Oxygen, that is 4 times 16 will give us 64 plus X 18. I think it's correct now. Let me be sure of what I did there. 16 times 4 will give us, okay, 64. So the next thing we are doing here is to, when we add up all these things together, 24 plus 32 plus 64, we have 120. So what we have here is 120 plus x18. x18. Now we are going to substitute everything. We are going to substitute them here. We have the mole now. We have 0.47 equal to reacting mass, which is 0.5 all over plus 18 x. So when we cross multiply this, we will have 0.75 plus x 18 bracket equal to 184.5. 184.5. So when we multiply through times 1, this one will give us 90 plus to give us 13.5x equal to 1845. So the next thing we do here is to collect like terms. If you collect like terms, you have 13.5x equal to 184.5 minus 90. That will give 184.5 minus 90 give us 94.5. This one will give us 13.5. That means x will then be 94.5 divided by 13.5. That will give us 13.5 divided, we have equal to what? 7. That is x is equal to what? What it means there is that x is equal to what? 7. X is equal to 7. So now we have done this. So the next one we'll be doing again. We'll be looking at some other ones. These are not all the questions that we have here, but then let's see how far we can go again. Let's see, we're going to be looking at the next question. And the next question we have here, okay, let me see what I can do here. So here we are going to continue with the rest of them. This question now, we have this is the fourth question that appear in that theory, in the theory of the question, past question, that chemistry practical question. And I want to encourage you to leave your question as in the question as comment there. I will always attend to you, and I want you to like. That's a way of encouraging us. And also, if you have not subscribed, I encourage you to do so. So here we have the first question we're going to be looking at here, continuation to what we have been doing in the past. The question we've been solving here, it said that calculate the mass in gram of oxygen required to burn 4.8 grams of calcium. Now, if you look at this, we are looking at mass that will burn this mass, 4.8 grams. So, barely looking at this, you find out that it's what we call stoichiometric calculation. That is, this one has to do with mass to mass. Mass what? Mass of this to mass of that. So, but before we can easily understand what is going on here, it's important we look at the balanced chemical equation of the reaction. That balanced chemical equation of the reaction is something that will look like this. We have it to be this. So from this balanced equation, we're able to find the mole relationship, which is 1:1, because we're dealing only with mass of this and mass of that. We're not interested in this based on the question. So now what we means that 2 mole of this will react with what? 1 mole of that, of oxygen. 2 mole of calcium will react with 1 mole of oxygen. Now, what mass? That means from balanced chemical equation, we can also find out the mass that reacted. Now, the mass that reacted, we know that to find the mass that reacted is mole multiply relative molecular mass or molar mass. So, the molar mass of this or relative molecular mass of that calcium is 40. We have 2 times 40. That will give us 80. Here we have 16 times 2. We have 32 multiplied by 1, we still have our 1 times 32, we still have our 32 grams. That is what we have from a balanced chemical equation. According to this equation, that is what we have. Now we are going back, we are taking it to what we are required to find out. Required. You understand? That is one of the ways to solve the problem. Now, we require to get what we need for this to be burned completely. So that means if 80 grams of calcium will require 32 grams of oxygen, then what will this one be? 4.8 grams of calcium. That will give us 32 over 80 multiplied by 4.8 grams. What we have as our answer there will be 1.98 grams of what? Oxygen. So in this case, anytime you have a question like this, it's important to really balance, have a balanced chemical equation of that. So in stoichiometric calculations, it's important to know, because from the balanced chemical equation, we will be able to really get to the end of the question. Now let's go down to the next one. Here, the next one is calculate the percentage composition. Percentage, calculate the percentage composition of sodium in sodium triazonitrate 5. Now, to do this, what we need, you know that percentage composition, percentage of sodium will be sodium over what? That of the whole compound where it's present. From the equation we have from here, we have this sodium triazocarbonate triazonitrate 5 to be what? 85 is 85. Then sodium there is what? Sodium is equal to 23. That means times 100 percentage. That's what, because it's percentage. So here we have 23 over 85. 85 times what? 100. That will give us 27.1%. This tends to be very, very simple. Now let's go to the next one. It says that calculate the solubility of a mole per dm cube of 4.99 grams potassium triazochlorate 5 in 20 cm cube of water at 66 degrees Celsius. So to solve this problem, we need to solve the problem, we need to know the amounts or the grams that can saturate 1 dm cube, because we're looking at it in mole per dm cube. Now we need to know the gram that can saturate it. From that gram that can saturate it, we can then find the mole per dm cube of that. Now, because we know that 1000 cm cube is equal to 1 dm cube, or equal to 1 liter. So here, what we have here, we are given, so that from the question there, we have 20 cm cube of water that is saturated with grams of potassium. So 1000 cm cube of water will equal to what? 4.9 over 20 times 1000 over 1. That will give us, let's use the calculator to do that to be sure. 4.9 times 1000 divided by 20. What we have here is equal to grams. So that is the amount that can saturate 1000 cm cube or 1 dm cube. Now that is not just the end of it. Now, since we know that, what else are we going to do? What we're going to do now is to get the amount in mole. Now we know in mole. So since we know that the potassium triazochlorate is the molar mass of potassium triazochlorate is 0.5 gram per mole. That is what we have. So to get the mole concentration of it will then be 245 over what? 122.5. That will give us that will be about 2 mole per dm cube. That's the last answer. Let's see. Divide by 2.5. Yes, it's 2 mole per dm cube. That's the solubility of potassium triazo chlorate at 66 degrees Celsius is equal to 2 mole per dm cube. Thank you so much for being part of the class, and we are happy that you get to this point and want to encourage you, to share. And then if you have any question, you can leave it as comment, then we can always attend to you. Thank you so much.